So we're asked to find all possible rational zeros, and the basic rule here is that if it's a rational zero means it can be written as a fraction of integers, and it's always the case that the rational zeros are going to be something where the numerator, the number on top, will be some factor of the constant, and the number on the bottom is going to be some factor of the lead coefficient. So normally when I have to make a big list, I start by looking at this constant and I think of all the things I can that go into that number evenly. So in this case, that would be 1, 2, 3, 5, 6, 10, 15, and 30. Wow, that's a lot. And then for the lead coefficient, it could be a 1 or a 2 or a 4. And the next thing I'm going to do is just take every possible combination, meaning I'm going to take every one of these numbers and put it over every one of these numbers, and if they'll make fractions, and if they reduce and they're repeated, I won't list them twice. So that's going to look something like, all of these different numbers over 1. So that'll be 1, 2, 3, 5, 6, 10, 15, and 30, and also the negative version of those. Then it'll be all of these numbers over 2, but I won't list things that show up twice. So for example, I'll have 1 over 2, and then I'll have 2 over 2, but 2 over 2 is just 1, so I won't list that again. 3 over 2 is new. 5 over 2 would be new. 6 over 2 would be 3, I won't list that again. 10 over 2 would be 5, I won't list that again. 15 over 2, and then 30 over 2 would be 15, I won't list that again. And then all the negative version of those. And then all these numbers over 4, and again, I won't list repeats. So that would be 1 over 4 is new. 2 over 4 would be a half, that's not new. 3 over 4 is new. 5 over 4 is new. 6 over 4 would be 3 halves, we already have a 3 halves. 10 over 4 would be 5 halves, we have a 5 halves. 15 over 4, and then 30 over 4 would be 15 over halves, that would not be new. And all the negative version of those. So this is all the possible rational zeros. Here's what that means. That means that if there are numbers that are rational numbers, that are like a fraction or a whole number, and if they make that this 0, it's going to definitely be one of these numbers. That's basically it. This is a huge problem too. Normally it's not quite this complicated, but the end of the day, what I need you to understand is we're talking about rational zeros, so we're talking about either whole numbers, integers, fractions, but nothing weird, like no root 2's, nothing that would require a crazy decimal expansion, just numbers that you learned about probably in 6th grade. We're looking for the values that would make this 0, so when you plug it in, a 0 pops out. And it's always the case that if such a number does exist, and there doesn't need to be one, but if there is one that exists, its numerator will go into this number evenly, and its denominator will go into that number evenly. So we always start by listing all the things that go into the constant, then all the things that go into the lead coefficient, and we try to list all possible combinations. So all of these over this, all of these over this, all of these over this. Reduce the fractions when possible, and don't include repeats. I hope that makes some sense. It's kind of what it is. It's like, don't overthink it. That's the rule. That's how it's going to work. If you really want to explore why it works the way it does, that'll kind of be explained more in pre-calc. Good luck.